The third part of Section 6.1, we want to talk about the notion of simultaneous events. So in slide number 13, we talk about what we mean by that. We can say that a collection of outcomes of the same sort of a probability experiment are called events. For example, if a die is rolled, that's a single dice, a pair of dice, one of them is called a die. The event that the roll is less than or equal to 3 is associated with the outcome of rolling a 1, 2, or 3. So think of that collection as an event. The event is being the outcome of the roll is a digit of 3 or less. All right. So what we want to do is we want to ask ourselves if two events can happen at the same time or not, under usual circumstances. All right, let's take a look at slide number 14 now and see how that works. So how about this? Let's determine if the following events can happen at the same time. Uh, the first event, let's see here. Think of when in the experiment, a person in a mall is selected at random. First event is that the person has a college degree. So you could go up and you could query someone to see if they have a college degree or not. And the second is that person employed? So the first event is the person does the person have a college degree, and the second is the person employed? Well, let's see here. We have to ask ourselves, can these two events happen at the same time? Can someone both have a college degree and also be employed? Well, certainly that's true. All right, since a selected person can be both a college grad and employed, these events can occur at the same time. In other words, they can occur simultaneously. All right. So that's something we always want to kind of keep in mind when we're doing these probability experiments. We want to ask ourselves, um, uh, you know, can events happen at the same time or not? All right. And by the way, if you contrast that with number 28 in section 6.1, you see those are two events that cannot occur at the same time. All right. One thing now, one final thing we want to make sure we look at here is the influence that one event has on another. In other words, um, does one event influence the outcome of another? So we can outline that in slide number 15. Um, we want to ask ourselves, is it possible for the outcome of one event to influence the outcome of a second event? And notice the note here, the common error here when we're doing this kind of analysis is to try to read too much information into the questions, into the problems to try to think of some kind of exception to the rule. Don't do that. That's where students kind of get themselves stopped all the time. So let's take a look at example 5 in slide number 16 so maybe you can see what I mean. So let's determine if the outcome of one event influences the outcome of the other. All right. So uh, think of event 1 as being Rebecca completes her political science course reading assignment. And then the second event being that Rebecca passes her political science course. So the question is, does the first event influence the second event? Well, one would think so. So for example 5, since reading an assignment can affect the grade in a class, we can say that the first event influences the second. All right. So we call those dependent events. In other words, the outcome of the second event depends on what the outcome of the first event. All right. Now let me finish up here with just some, I guess, general tips on computing probability here. That's in slide number 17. Make sure to read the problem closely and think carefully about what you're trying to solve. In other words, would the answer be a word, like we did with the good, fair, and the poor, or would the answer be some kind of number? So ask yourself, what's the answer going to look like? And second tip, for the question being asked, ask yourself whether or not the following three apply. Is order important? Is there a ranking involved? Second, can the events occur at the same time? Can they occur simultaneously or not? Those events are called mutually exclusive events. Those are two events that cannot occur at the same time. They're called mutually exclusive. And third, can the outcome of one event influence the likelihood of the other? So, in other words, this notion of independence. Part three, I talked about this before. Don't conjecture and try to read too much into the problem. And finally, interpret the solution. Answer the question being posed using a complete sentence. All right, so finally, for homework in this section, uh, there's no computations or anything to do in this section. We want to read over section 6.1, look at the examples, and we're doing problems 1 through